Morning. Okay, I've had some questions that get sent to me about this exam one group discussion that you're supposed to be working together as a team, and a few groups have low numbers. So I'm going to move things around after class. So hopefully you'll be able to either be moved into a group that will be participating. If it still ends up that there's not a group participating with you, go ahead and just submit your own work so that you can get credit. So worst case, if you don't collaborate with anybody today, just submit your work you have done. Okay, any questions on that? Yes. You can go ahead and upload that. If they did participate, yeah, just include them in there, even if they move groups. That way they can make sure to get counted. I'm assuming they'll still post those, so it might get posted twice, but that's okay. All right, any other questions? All right, exam one will be on Wednesday. So it will, you can start, whenever you start it, it will go ahead and start its time. So you can start a few minutes before and then have it go throughout. So it's going to be, 8:05, but 8 o'clock if you want to come in a little bit early. It's just timed for I'll do it at 100 minutes. So if you want to take that 10 extra minutes, either on the first end or the tail end, you can do that. So if you have a class right after, I suggest starting a little early. And so you'll have 100 minutes. Class is only 90 minutes, so you can do it 10 extra minutes. So whenever you start it, it will just automatically end. So just make sure you do watch time so that you can upload your work for partial credit. So upload work. So bring a device. If it's your phone and you already have the app on there, I suggest that. So just make sure you bring your device. If you don't have a device, that's okay. Still, there is a scanner in the room. And it's going to be in the Engman lab. It's here in the web. And the room number is 210. And so bring scratch paper. Calculator. So you can either use an online calculator and you can bring your own computer if you want to. For anyone attending on Zoom, just log into the Zoom account like you normally do. And then again, there'll be an additional verification. So if you do it on Zoom, especially for you guys, if you end up taking it on Zoom, I will set up a schedule so that we can meet one-on-one, and I will do another verification step to verify that the work was yours from the exam. So that will be just another extra step just to verify that you are doing your own work. So you can use online resources, online notes, online calculator. If you want to, some people asked me about the script that I mentioned before. So for me, I used Python and I wrote a little script where I can put in some information and then it will just do the equation for me. So if you want to write a pre-MATLAB, little code that you can do that, you're welcome to do that. Only thing you cannot use is a simulator. So a circuit simulator is the only thing you cannot use. Okay. Otherwise, you can even use, I'm fine with you even using MATLAB. So if you want to write a few little codes that you have saved, just make sure to take a screenshot of whatever you're using in that online calculator. And if you use an online calculator, take a screenshot of what the results are so that if there was a mistake made there, you could still get partial credits for it. Okay. All right. Any questions about the exam? Logistics wise? All right, content. So the possibility of types of problems, RL circuit, RC circuit, RLC circuits. So those are the type of 3 problems that you'll see. So make sure you know how to do all 3 of those. And then as you saw last time, there'll be concept questions. So concept questions can be as simple as, in your own words, describe what WD means. What does that variable mean? So that could be a question, or it could be if I wanted to change this to be specific things. So one thing I asked last time was the circuit we looked at was like an RLC circuit that was, I don't remember which one it was, but say it was a series connection with an underdamped. And the question that I asked was, well, if I want to change it from an underdamped condition to an overdamped condition, what would I do? So those kind of concept questions to know that verifies, what factor is affecting that variable. So that's the other understanding is the equations themselves and what effect do they have on the circuit. So if I change the capacitor, how is that changing alpha or omega naught? If I change the inductor, how is that changing alpha or omega naught to change me from those different characteristics of how it transitions from the initial and the final state? Does that make sense what the concept questions would be? Okay. All right, so that's all the content, right? So not hopefully any new surprises of what's going to be on there. The next question is, how do you do these 3 types of problems again? So let's do a review of these. Let me. Just gonna grab a circuit. So this would be an RC circuit. I'm gonna change it slightly, maybe. I can get it to move. Change it slightly so that it won't be as. Okay, so we want to write an expression for V2 of t. Switch is closed at t equals 0. Oops. Okay. So where do we start? Okay. Okay, so that could be a good place to start. Simplify circuit if you can. We're just going to write out the equation, the steps again quickly. So simplify circuit if you can. Then what would you do? Do what? Okay, so, or I call it the general form equation for this. So we know it's an RC. So we would write the general form equation. So for this case, V2 of t equals the final. I always forget this, so. So final plus initial minus final. E to the minus t over tau. And for C, tau is 1 over RC, RTHC. Yes.
What are some how do you solve when the circuits at infinity or initial?
Final, always final. Yep, final state. Good question. So always remember for tau or alpha, maybe not, all of those are going to be the final position. So from here, find unknown variables. So in this case, initial, final, and tau. All right, so I'm going to put you guys in a breakout room. All right, so please look at your solution and the solution up here and see if you were able to get the same values. So initial value should be 0 because the circuit is open and there's no connection to the capacitor, and that acts as an open. And then when you go to T0 plus, remember that is the circuit. If you have any other variable in there, that's the circuit you're going to use to find that initial value. So make sure to make that note. And in this case, it ends up being still 0 because we're finding the variable across the capacitor. So initial value 0. Final value, again, it acts as an open. And then note that there's no current going through this 20K. So there's no voltage drop there. So the node above that 1K or 3K, sorry, the node above that will be your VC or V2 node. And so I use node voltage to solve for that, and that ends up being a -7/5. I think that's -1.4. So that would be your final value for VC. Put it all on there. And then for tau, it's RTHC. And so for RTH, again, that final circuit is going to be where you find tau, final circuit. And you put A and B across the capacitor, and then the pathway between A to B. So the pathway here goes through the 20K, and then you can see that there's an extraordinary node and it's going to split. So it's 20K plus 3K in parallel with 7K for 22,100. And then multiply that by the 40 micro from the capacitor, and that gives you tau, and then plugging that into the general form equation. Yes, questions?
So why don't we have the 2K and 3K? Why can't we do that?
So it's just because of the pathway. So as I move through here, there's no, here, let me mark the extraordinary nodes. So if I highlight my extraordinary nodes here, this is an extraordinary node. And this is an extraordinary node, right? So between A and the 20K, so anything that is that has the same colors on the top and the bottom of their elements are where you have a parallel connection, right? Okay, hopefully that helps.
Yeah.
Okay, so color your nodes again if you want, and then you can see between the 4K and the 3K, hopefully that's obvious that that's 7K. Yes. May not be marked. Because I may take problems from different places. So where would you put your node as far as ground here?
I don't even know where the ground is. Okay.
So whenever, so you want to put ground, if you don't have a ground, you can put ground anywhere you want in the circuit. And so that means, or the most likely, or the most beneficial place to put it is a place that has the most extra, like can't talk today, sorry. You want to take the spot that has an extraordinary node with the most connections off of it. It would be the bottom one, right? Can you see on this one? So here, oh, I mean, you have the same VC are down there, but if you're finding VC, you don't want to put the ground at VC.
Right, I was just, because if you put it around on the bottom,
Uh-huh.
then the voltage source is.
So if I put my ground here and I measure at this spot, that's going to be -2 volts. Right? Because it's between the top of the, that's between the battery.
Yeah.
If I measure up here, that's where my VC is. And it's across the 3K and that 2-volt battery. So I typically want to put that ground as reference. I like to put it always on the bottom of my graph if I can. So I tend to try and put it at the bottom with the most extraordinary node that has the most connections off of it. So that's why I put it at the bottom. So if it's not labeled, look for similar locations. And yes, there is at VC, there's a lot of connections off of that. But I'm trying to find VC there, so it doesn't make sense to put my ground at VC. Does that help?
Yeah. It's just, play the crowd right next to it.
Let's do this. Visually, I can see what you're saying. It's hard to see that, but just think about it. It's just a battery. So you're just putting ground at one side of that battery. I don't know if that helps to visually see that. All right, yes, William.
Can I see what the final answer is? Okay, that is.
Okay. Katie, go ahead.
Oh, sorry, she's answering that.
Oh, she's explaining. Okay, is there other questions? Have any questions online? There you go. That. All right, let me grab a problem for.
Oh, wait, can I see the initial circuit?
Yeah, just a sec. Okay. There we go. RL.
Okay, that's. So it's 20. That's.
All right, any other questions about that problem? Okay, let's move to an RL problem. So we'll do this one. I apologize, I didn't get time to post these before, so I will post these today so you can have these notes to study off of. But in the meantime, go ahead and draw this circuit. Yes. Yeah.
I was trying to use a divider to find
You were trying to find a what divider? A voltage divider?
use a voltage divider, let's say combine like the main and
Okay. Three K, 7K. So if this was it, you would do a -2 times 7K over the 10K. What did you do? So you could find that too, but if you found the 3K, the VC is going to be the voltage across 3K and the -2 volts. right? Because it sounds like you just found this one, which would be V1. Right? Because it's only across the resistor that when you find that division. Whereas across the 7K is all the way to ground, which is what you're trying to find it from. So if I put ground here. So we can do it both ways. So this would be minus 2K times 7K over 10K, which will give you the minus 7/5. Or find V1, which will be a minus 2 times 3K over 10K. But then VC is a minus 2 plus V1. And that should be the same. Does that make sense?
Yeah.
So hopefully you can see that when you take the divider, it's only across the or across the resistor that you're finding the division for.
That's why I kind of mentioned. When you do a voltage divider, it's the ground. So like what's R1 and R2? So without a ground, R1 always.
Yeah, you should put in a ground. I can see it myself, so I don't always put that. I apologize if I forget to put grounds in there.
Yeah, it's just like a channel where you put the ground, you get like. Because R2 is in reference to the ground. You know, like how the voltage divider.
Yeah, so I mean, yes, it's gonna get confusing if you put ground somewhere else, because if you put ground, then V2, when you find it, if it's not ground on the bottom, you have to find that node voltage itself. And then it's gonna be the difference between the top and the bottom.
Yeah, that's why I like having voltage marking follows.
Ground in the problem.
Yeah.
Um,
Can we do it ourselves?
Yeah, I can see that. I will try and mark with the grounds for you. But do know you're gonna see things that don't have grounds, and you would need to know kind of where do you want to put them.
That's just bad. If someone doesn't put a ground in the circuit, that's just. It's hard to.
So,
Like in every.
yeah, you have to put ground in there. It's not that it's bad design, it's just preference. And as you get more and more familiar with circuits, you'll start to see like, oh, okay, it doesn't matter if I have a ground, it becomes more obvious, I guess. But I do understand at your level, it's only been a year you've been seeing these. I will try to put those grounds in there. Okay. All right, so where do I want to put the ground here? Okay. Put this in at the bottom node, yes. Okay, all right, so we're gonna do this circuit and same steps, except for now that the tau is gonna be different. So we have tau is, what is tau? Everybody?
R over L.
L over RTH. And then it's going to be the same. You're going to find IL of T. It's going to be the final value plus initial minus final. E to the minus T over tau. So in this one, the switch is starting at 1. And then it moves to 2 at time equals 0. I'm gonna draw it here first. Okay, so it 1 first, and then it switches to 2. So what is my IL of 0 gonna be?
0.
Thank you. Okay, so IL of 0 is gonna be 0. So switches here, and this is a wire. And there's no current gonna flow because there's no sources. So IL of 0 minus is gonna be 0. Actually. So again, for the initial, if I ask for a different part of this circuit, this will be a current source with 0 amps. And then that would be the circuit I would need to find wherever the other initial value is. Okay. So in this case, though, the I is the same, so IL is still going to be 0. And so this is my initial value. For the final value, you're going to have the circuit will change to 2. And again, this is a wire. What do I notice here about? Yes. Okay, good. Whoever said that, it is short circuited across the 3 ohms, right? Because of the wire across that. So you're going to ignore this. And we're finding the current in the branch. So this is just going to be IL is 12/6 for 2 amps. And that's my final value. So you could either look at it as the path of least resistance, or you can say, okay, I have 0 ohms in parallel with 3 ohms. If I take the equivalent of that, it's going to be 0/3. So it's going to be 0 ohms still. And that's why it is still the path of least resistance. But mathematically, you can do it too. Again, if you are not seeing these, highlight still all the wires so that you can see that they are in parallel. So if I was to highlight these colors, say color this one. This would be everything that I would color, and that makes it, I think, a little bit more obvious that this would be the 3 ohms is ignored. Okay, so then I use this final circuit also to find tau. So again, final position for tau. Which means that this is going to be a wire, my A and B. And then any independent source I remove, a voltage source is a wire, and a current source at 0, it looks like an open. So now RTH is going to be what here? So if I color these again, Yes,
An inductor is a open circuit at the final.
no, it's a wire, but when you find tau, you're trying to find across the A and B of the inductor. So that's why I put A and B. I take it out and I put A and B at the locations of where the inductor location is.
This is for our thing.
It's just for the Thevenin portion, yes. So in the final position, so final circuit is shorted where you have a wire because of that. But when you find tau, you're taking out the element and finding A and B, the equivalent resistance it sees across its terminals. So that's why you open it up and put A and B location there. Does that make sense? Okay, so what is this circuit going to be for the Thevenin here? So 6 and 3 are in parallel. Okay. Is everybody seeing that? Color them still. If you're still wanting to color them, that definitely still will be helpful. So please color them still. So 3 in parallel with 6, which gives me 2 ohms, right? 18/9, so 2 ohms. So now my general form equation, my final value plus my initial minus final, e to the minus t over tau, which is L over RTH. And L was given as 1. So I can actually write this as minus 2t. So this would be this one here. All right, questions? Anybody have questions online? Sorry, there's some questions here. Yeah. Okay, you guys got that answered. One question online is about having assessments. So today there's no assessments and no quiz tomorrow. So instead it's just that group 1 preparation for the exam on Wednesday. Okay, so that was a question online. No, there's no assessment or quiz today or tomorrow. All right, questions about RCRL circuits? Yes. Okay. Yeah, if you want to bring it up.
So and this, so you're trying to find R7.
Uh-huh.
So you'd just go from A and B right here, right? Then this would be open and this would be open. So does that mean R is 0?
Yep.
So would R be 0 on
Yep.
that page?
Yep.
So would you divide by 0 if you're trying to find alpha and omega?
Yeah, I see what you're saying. Okay, so question about the RLC circuit. And what if you find our parallel? Grab the. Okay, so his question was, if I find my R to be 0 when I'm in the parallel form, what happens here? So his question was, okay, so I gave an example where in series, I had the R was 0, which means alpha is 0, which means it is always going to be less than omega naught. But what about the other situation when alpha is, or R is 0 in the parallel case? Do this. So there can be a situation where, again, we have an R is 0. And what happens here? So 1 over R 2RC is going to be what? It's going to be 1 over 0, which is, it's infinite, right? Which means that it is always going to be greater than omega naught. So then you would have the overdamped situation. So that, hopefully that answers your question. Okay, other questions? Yes.
Wait, so in that case, how can I get the R or alpha is infinite, how can I say S1?
They would be infinite too, right? Yeah, so there's no roots, there's no solution.
1 over 0 under 5.
The limit of 1 over 0 goes to infinity. Yeah. Do you want me to say it that way? Limit of 1 over 0 goes to infinity. So anyway, this will not be an existing case. So hopefully that answers your question.
Or
You
negative.
won't see this situation. Yeah,
What happens when an alpha is infinity and it's, I understand it's overdamped. Yeah, so therefore you have no smoothness. So does that mean there's no equation either?
it basically does not exist.
Okay.
So hopefully that, so you're going to get a case that doesn't exist. Because there's no solutions, can't write the equations, so. All right, other questions, comments, concerns? Okay, so let me grab another, so we'll do an RLC. If I can find a circuit RLC. Open. All right, do you want parallel or series connections? Okay, are you getting very different? Okay, a vote for series connected RLC. Vote for series. Okay, vote for parallel. Okay, we got parallel. Looks more. Okay, we'll grab this one. Oops. Oh, whoops, I grabbed the wrong one. Delete. Open. Okay, this is the parallel one. All right, go ahead and take,
Wait, that's supposed to be parallel? It looks like a series.
again, where do you find where it's in series or parallel for an RLC circuit?
Well, yeah, but that thing opens up at 0.
Uh-huh. At the final circuit is where you're going to determine if it's in parallel or series. So this final circuit in this case will have it be open. And that means that the inductor and the capacitor are in parallel together.
Yeah, it looks like a series
All right,
one.
it is, you're right.
It's the morning.
Okay, it's early morning. You're right. Okay. Okay, here we go. This one will have. Okay, if this is closed, then at the final one, we're gonna have these two in parallel. Thank you. Okay, we got a parallel here. Open, yep. All right, which one do you guys want to find? IL, IC?
IL looks like it'd be easy. IC would be the thing that probably be the.
IC is going to be harder
Yeah.
because IL is what you'll need to solve for. So do you want to do IC to make it harder?
Yeah, do the harder shit in class.
I won't make you do a crazy derivative. Okay, he's asking if I would give a crazy derivative on the exam, and I just said no. I won't give you a crazy derivative on the exam.
So for this specific question, is the final power or the word? Are you expecting us to know how to do that?
No,
No, okay.
no, we have not looked at that one. So she asked, if you guys didn't hear, will I ask about the power and the energy on the exam? And we haven't really talked a lot about that. So no, I will not ask that on the exam. So good to kind of know what it is, but we haven't done problems on that. Okay, fine. Why don't we find ICE? Let's do IL and then I'll look at like explaining the others. So IL. All right, for you guys online, I'm going to put you guys in breakout rooms.
Yeah.
All right, so here's the solution.
Oh, we'll need a.
So take a second to look at this. If you have any questions,
What?
I'm happy to stay after and answer them.
Differential equations. We'll be using that. Or we'll get
We have done some examples, like in this case, if you know IL, you can find BL by just taking the differential on that.
and those, because I heard in the TA in the lab, it says that they said that these things works together. So if you want to, let's say, find VL, you can just use this formula. And I don't know if that's true or not.
Yep.
You can do that.
Uh-huh.
And what will you do? What will you replace C and IC?
So in this case, like if you wanted to find DC instead, you could do so you would go through the same circuit. You would just do it from the perspective of the C side. So when you find
So this works. This is the same. There's no like, there shouldn't be like divided, right? Because if you want to find, let's say you want to
yeah,
find B,
so you should find, it should be critically damped here too.
right?
So then when you find VC of 0, you'll go to this circuit and VC of 0 would be 15 volts, and then you need IC of 0. And so if you have 15 volts on both sides, IC of 0 would be what in that?
Wait,
It would be 0, right?
yeah.
So that would be your initial IC of 0. BC of 0 would be 0, and then BC at infinity would be again 15.
Okay, so you don't really need to use this formula, then, right?
Correct. You can do it either way.
Either,
It should end up being the same. I just haven't had time to go through those yet to show, so most likely you're not going to see that on the exam.
And for series and parallel, it doesn't really. I'm just like confused on this table because I always assume that for a series you can only find VC, but that's not true, right? You can also find VL using this formula, using this.
Yep.
Okay.
You would still find alpha and omega naught based on the
series.
based on the series or the parallel.
Okay,
connection.
that's like the only thing that's differentiated.
Yep.
It's just the A.
Yep, and then the equation itself, though, after you
Right.
find which one it is, and you find those values based on the configuration. So alpha and omega is what's different. So in the series for RLC, you're finding it from the series C side connection.
Yeah.
And then this one, you're finding it
Okay.
from the inductor location. That makes sense. So
That makes
those are what will change
That makes perfect
depending
sense.
on what you're trying to find, but then the equation itself will be the same. So you can see here, it's just the variable difference between the two.
Yeah. Okay. Cool. Thank you.
So if we're gonna take the quiz online or
Uh-huh.
the test online, we just have to be in the Zoom with a camera on us.
Yep.
And then the test will be on Canvas then, right?
Yep. Uh-huh.
Okay, cool. And I just, one more thing, my group, we only have like 2 members working. So like me and another guy,
Okay.
if we upload our group, can we like get full credit if we do
Yep.
like all 3 problems?
Yep.
Okay.
Yep.
Okay, cool. Thank you.
Uh-huh.
Hi. We can take the exam on Wednesday on our own computers, right?
Yep.
Okay. I just wanted to double check.
Yep.
Thank you. Just want to check out, are you gonna all log today these notes?
Yeah.
Because sometimes.
I know, sometimes they're a little late, so I will try and get these up quickly.
Okay. Perfect.
Uh-huh.
And like during the test, we'll be able to like access like the notes that we already had in the handouts, right?
Yep, so you will have access to the page. So.
I'm sorry, ma'am. The exam on Wednesday will be related to the basic of L and, sorry, RL, resistance and capacitor.
So it can be either just an RC circuit. You know, this was an example of an RC circuit, and you'll need to find all currents and voltages in that circuit.
Yes.
Or an RL circuit where you need to find currents and voltages in that circuit, or an RLC. An RLC, you can have series or parallel connections. They can be overdamped, parallelly damped, or underdamped, and being able to describe the whole equations, voltage, current, voltage and current expressions.
Yeah. The room will be L210
210, yeah.
down.
Yeah, just downstairs. If you go out this door and there's a stairwell, you can go in one floor down, and then it's just.
I will try these 2 days to
Yeah.
to do some practice about it.
Yeah, so if you are not successful like this one, I do a repeat in the final.
Yes.
So just by the final, you need to make sure you've mastered that material.
I will try.
Okay.
Thank
Yeah.
you. Thank you. very
Yeah, I
much.
know you started late, so yeah, you'll have an
I-
option to retake.
Till now, I didn't resolve, but maybe I will buy a new computer because I didn't resolve how to connect my computer.
Yeah, were you able to go over to the Marriott Library?
Today, after I finish
Okay.
I go there.
Yeah, and Brandon can walk with you if you want him to walk with you. He was,
Who?
Brandon,
Yeah, Brandon, maybe.
Yeah. if you want him to help you with
Yeah,
that,
yeah,
he's
yeah.
like, I'll try to be available. So,
Thank you.
all right,
Thank you.
see you, Mohammed.
I'm Alex. I don't know if we're meeting right now, but I'm the one who was flagged for academic misconduct.
Oh,
for
yes,
cheating.
yes,
Yes.
thank you. Yeah. Hang on 1 minute.
Hang on. All right.
Yeah.
I was planning on taking the test online, and you said today that we would have to schedule with you what time we would have the Zoom.
Yeah, or if you want to, if you've been here in person just after. So just attend on Wednesday at the same time as here, just in wherever location you want to be. And then I will just connect with you after.
Oh, just in the Zoom. Okay.
Yep, and then
another-
it will just be more like, if you're here in person, it will be easier to be like, okay, just answer these questions about this.
and then
That's all it will be.
for this, we were solving for IL in the recent RLC, but if
Uh-huh.
we were solving for IC,
Yep.
we just changed the subset and everything else would work. Right?
So you can, you still have to use the relationship because it's either. Yeah, I guess, yes. I haven't gone through those examples, but yes, you
Yeah.
can, but there's a few little details that you gotta be careful about. So, yes, you can. You just have to be careful of those.
And then one
details.
more thing. Whenever I go onto campus to find the website you were using, I can't find it. Can you just show me one more time
Which,
where you got the practice? Yeah.
oh, the practice problems.
I have-
Okay, yeah, let me go to our page and I'll show you from there. Maybe. Okay, so if you go to the learning materials,
I keep looking for this tab. I don't know why I can't find it. It's probably. I probably just closed it out.
so just under the Unit 1
Unit 1 learning materials.
learning materials. Did you see where I went? Sorry.
Mhm, mhm,
Okay, so then just go down to the book and then it's companion website
mhm.
and then let's see, answers questions. Let that go. Test your understanding.
Oh, it's okay.
And then that's that page.
Thank you.
All right, no problem.
I just had a quick question right here.
Mhm.
This was the equation we got, and it had I of t, and I forgot that part on the.
Yep.
And I forgot the amps as well. But if we're trying to find I of c, wouldn't we take the derivative of this right here?
So IOC, you are gonna have to take. back to this. So IOC, is gonna be a little different, because it's gonna be, C, C, T. So you have to find
Oh,
V of C, so you're gonna have to use this to find VL, LDI.
GT.
So take the derivative of this to find VL, and then take the derivative of that to find IC.
So you'd have to first take the derivative of this function and multiply it by L, right?
Mhm. And so it's basically the second derivative.
And
'cause
then
you
you'd have to take,
differentiate this and then differentiate again.
okay,
So that would be your IC.
okay, thank you.
That'd be one way to get it. Uh-huh.
And then can I ask one last question?
Yeah.
Will we see like previous exams that have been taken or like previous exams of previous years, or do you not do that?
Say that again.
Sorry,
If,
like, do you post exams of previous years that people have done the test or like the unit 1 test or no?
this is my first time teaching this, and so I don't have previous exams,
Okay,
but I have used Dr. Cotter's previous exams as examples throughout. So all of those examples are from previous exams, like that were underneath the learning materials.
all right, thank you.
Does that make sense?
Yeah,
Okay. Yeah, so I don't have exact ones because I've already used them as examples in there.
all right, thank you.
So I'm a little confused on the RC.
Uh-huh.
When we found the